would like to understand your thoughts on how do you define DFM, because it has been practiced in the industry for more than 30 years now. So how do you define DFM?
The DFM stands for Design for Manufacturability, as you know. And there's a difference between the metals world that we, as a mechanical engineer, that we've been used to and educated in. Metal worlds, if you design a part and it's manufacturable, then you have pretty much done your job. Plastics are very different. Plastics, I would use the term design for performance and manufacturability.
So we just wanted to understand from you what kind of benefits an organization can derive by having a proper DFM strategy in place.
Okay, let's take them one at a time. In cost, there's opportunity costs, there are part costs, and then NRE costs. Opportunity costs are costs related to losing the potential sales of this product for 4 to 6 to 8 weeks that you did not have the product ready to be shipped. You had committed to the product to be shipped on March 1st, but it's April 15th and April 30th, you will not ship the product. In the meantime, the customers are not buying the old product because the new product's coming. And so this opportunity cost you'll never be able to recover. It could be hundreds of thousands of dollars, or it could be millions of dollars. Part cost is obvious. If you have poor yields, if you have to make 10 parts to get 8 good parts, then obviously you're paying for 20% scrap. And then there's the NRE cost.
If you could just elaborate what you mean by the NRE cost.
NRE costs are the one-time costs of developing the product. You know, engineers' time, technicians' time, toolmakers' time, processing engineers' time. That's a one-time cost to create the product plus tooling cost. So these are all NRE, non-recurring engineering costs, one-time costs. Now normally you budget for X dollars NRE, but if it becomes 1.1x, 1.2x, then it's a problem. It affects your profitability.
Vic, just last question. So how any of the DFM tool can help as a knowledge management tool in the organization?
So if we, you know, before we do anything as engineers, as anybody, as a thinking person, we need to know why. When I say the wall has to be uniform, you need to ask why. So if we use DFMPro and we hyperlink information on why corner has to be radius, why the wall has to be uniform, then when the engineer designs it and it comes out as an error, this corner is sharp, he or she can look at the knowledge base that we have collected, that you can link the DFMPro to, and really understand why this is being done. Engineers are strange animals. They will only do something that makes sense to them. They will not do it because you told them to. So this is a way to convince them that, hey, there's a reason for doing this, and therefore we want them to be willing partners to do it, to run DFM, not because we are asking them to do it. If they're doing it because we are asking them to do, engineers are very clever. They'll find ways around it. Okay, so it provides a very good why, and then we have the same common tool from the engineer to the tool maker to the processor, and they are all playing with the same rules, with the same knowledge base. Now they all play with each other. Yes, I know that DFMPro was run, so tool maker is confident that my part will fill, or there'll not be a problem with a net line in the wrong location. And now the processor is happy that the tool will be the tool and the design will be optimized for processing. So it's across the board, from the designer to the tool maker to the processor. They're all playing this by the same rules, and they know why they are doing what they are doing.